So in this chapter, I want to talk a little bit about experimental research. This chapter and the four chapters and the three chapters after this chapter all deal with the techniques that are used in quantitative data. And so chapter 9, chapter 10, chapter 11, chapter 12, these are all building on a positivist approach, or one where truth comes to some extent through quantitative research. Now, the question would be, what types of research questions are the appropriate ones for where you would use this kind of experimental research. And you would use this kind of experimental research when you're trying to see whether a causal relationship exists, when there are certain limitations, primarily practical, that prevent you from looking at an entire population. You're also looking at situations where you can reduce the extent of manipulation of the individuals that you are speaking to, but also primarily experimental research is incredibly useful when you're looking at micro-level data, meaning I'm looking at very specific data variables for an incredibly well-specified group of individuals. Okay, so if we look at the history of experimental design, it largely comes from psychology, and that would be Wilhelm Wundt. When we're looking at this history as well, we look a little bit at behaviorism. In behaviorism, what we're doing is we're trying to emphasize the creation of precise measurements of observable behavior. What we're trying to do is we're trying to take behavior that we can take note of and see that as a way in which it's manifesting something internally, right? So it means something like, let's just take an extreme here, right? Like if I am starving myself, that would be the thing that you would see, that might reflect, an uncomfortable family situation that I've had that's encouraged me or made me feel guilty to eat or have certain body issues, right? That would be an example of behaviorism contained in that. And then we have the issue of quantification. That means that I'm trying to measure some social phenomenon with numbers. Now, what you want to do is you want to introduce anonymity into the experimental design. You want to do this so that you don't get emotional engagement of the researcher in the design itself. And you also see experimental design used quite heavily in applied research. This would be applied research that's used by businesses, the government, schools. All these organizations use experimental techniques to determine whether they're funding of certain research, whether it's justifiable or not. So one way you could think about how you would undertake the experimental research would be with random assignment. And in random assignment, what I do is I have an entire pool of subjects or individuals that would be eligible to be spoken to, and then I randomly, let's say every other individual goes into either the experimental group or the control group. Now, it's incredibly important that this be a random assignment. You don't want to be using anything other than a random pick of an individual belonging to one of these two groups. It's not based on whether it's justified or whether someone deserves a specific area here. It's really incredibly random, and that's important. What you could do as well, instead of creating a control group and an experimental group, what you could do is you take your entire population and you just draw a sample from that. So you don't have a control group and whatnot. Now, you can see here that it's all going to kind of depend on what kind of study you're doing. Is it important to have a control group? We see control groups used in, let's say, I'm trying to study a medication, right? And if every individual is alike except some individuals took a medication and some didn't, then I could have some level of confidence that the medication caused the change, right? I'd have some way to show that there is a causal relationship. In this kind of random sampling, it's not as important that I have the control group for whatever reason, just depending on what the process was. Okay, so here would be how to randomly assign. Well, kind of dismiss this just because it is incredibly simple just to determine when you have your entire collection of groups just who belongs in a control group and an experimental group. Simple way to do it would be flipping a coin. Writing a 1 and 2 on note cards, passing out the note cards to everyone. All the 1s go in one group, all the 2s go in the other. Again, completely random. Now, in random assignment, just skipping to the second part here, in random assignment, you don't have characteristics that you're trying to match. You're just randomly determining one group in control and the other not. It's in matching that you're actually creating groups based on the fact that individuals or the cases, the subjects, meet certain characteristics. So maybe I could have a group where it's married individuals, another where it's single individuals with child, another where it's just single individuals, another for divorce, right? I could think of different characteristics and in those characteristics match those individuals to a certain category. Now, in the experimental design, there is a logic, and what that logic does is it gets me starting to think about subjects, treatments, post-tests, pre-tests, the experimental group, and the control group. Now, when we use the term subjects, as you saw in the previous slides, all we're doing here is that's what we're calling the participant, the individual that is part of the experiment. Whether they're in the control group or the sample group, doesn't matter. Now, the treatment is what you do to them, right? In the case of a medical exam, it's pretty easy, right? It's the fact that one group took the medicine and the other didn't. So that would be my treatment. The pretest would mean that I'm looking at some characteristic before the treatment. So let's say it's a cancer drug. Let's make it kind of simple here. If I'm looking at a cancer drug, in that pretest, maybe I would measure the size of a tumor, right? Or some other I would conduct some other kind of medical test before I administer the medicine. In the post-test, I am then reconducting that test after they have taken the medicine. In the experimental group, that would be my group that does get the treatment. In my control group, that would be the group that does not get the treatment. Now, the classical way that the experimental design occurs is that you start out with the hypothesis. So if we extend a little bit further this idea of the medical exam, right, or the medicine that I'm going to give to the individuals, what I'm probably saying here for a hypothesis would be taking this certain medicine reduces the size of a tumor or whatnot. Then I have a design choice. The design choice would be, is it necessary to have a pretest or not? Maybe it won't be. Do I need a control group? Maybe I don't, right? It could be just like the other slide where I just had individuals having a sample with no control group. Then I need to think about how I'm going to design the experiment. How am I going to introduce the independent variable? How am I going to measure the dependent variable? Right, so it's going to matter for the independent variable, how am I going to deliver that medicine, right? At what point will they be given that medicine? How will they be given that medicine? All those things matter. And then for the measurement of the dependent variable, I want to have something that standardizes how I'm measuring tumors or whatever it is that I'm measuring. Then you have some way that you're locating the subjects, right? Maybe I put up signs at a hospital, maybe I talk to some doctors and I get some of their patients. Then I have my random assignment of the subjects to the control group or the experimental group. I then have individuals conduct the pretests and then run the experiment and analyze the data. This slide right here, if you're doing a project that involves experimental design, I strongly encourage you to focus on this slide because your later research assignments are going to have a design much like this. Now, in an experimental design, it is absolutely critical. I'll repeat that again. It is absolutely critical to to control all the aspects of the experiment. You need that control because you want to make sure that you have only one other thing changing so that I could say, yes, it was taking the medicine that caused this. The more that you control the aspects of the experiment, the easier it will be able for you to establish a causal relationship. Now, you want to be careful about deception. Deception would mean that the experimenter, in this case the person conducting the experiment, is essentially lying about the true nature of the experiment or creating false impressions. To have deception exist introduces a host of other concerns about the experimental design and may lead to critics not trusting your research results. And when you're conducting this deception, I guess you would also need to then think about your confederate. The confederate would be the person who's working for the experimenter, who's acting as another participant in order to deceive. So basically what that means is that a confederate would mean, in popular terms, we call them a ringer, right? They go out into the subject groups, let's say I'm talking about marketing and whether it's persuasive. So I could hire an individual, me as the experimenter, hire an individual to go out there and then sit in my group of individuals that I'm going to be giving the treatment to. And that person would be sitting there and saying, oh my God, I'm really intrigued and being informed by this marketing, right? So that confederate is setting the seeds of like, wow, this is really influencing me. That causes obviously a problem, and that's part of your deception as well. Again, having confederates in the sample is going to lead to your results beginning to be questioned by others. So here is your classical experimental design. I have my random assignment, that's my R, and my random assignment is leading to two groups, a control group and an experimental group. Then the X stands for the treatment that's given, and then I'm doing a post-test in this last set of circles, right? So I'm doing a pretest here, giving the treatment to just one group, and then determining with a post-test what the relationship it looks like. Again, what I'm trying to do is establish a causal relationship between X, the treatment, and the independent variable. Now, we could think of some other pre-experimental designs. That would be the one-shot case study, right, where I just give the treatment and then I do my post-test. I could have one group p-test post-test, where, again, I just have a group that's given the pre-test, the treatment, and the post-test. Or I could have something called the static group comparison, where I'm giving the treatment and then doing a comparison of two different groups here. The type of experimental design you use, it's all going to depend on It's all going to depend on what you're trying to study. Now, to the extent that you see in here that none of these involve random assignments, these then, by a result, have a weaker design than the classical experimental design. So you really don't want to use these pre-experimental designs if you don't have to, because again, they don't involve randomization. Now, we could think of some other quasi-experimental designs. Now these are a little bit stronger than what we just looked at. So these are a little bit stronger than the pre-experimental design. These are all variations on the classical experimental design. And you would use these primarily when the person, the experimenter, has limited control over the independent variable. So in the two-group post-test only, you essentially are randomly assigning the two groups in a post-test situation. In the interrupted time series, what I have here is an experimental plan, but what I'm doing here is I'm looking at the dependent variable across multiple time points. In the equivalent time series, what I'm doing is I'm using an experimental plan, but I'm using repeated pre-tests, post-tests, and treatments for one group. And it's that repetition that gives the equivalent time series a little bit more of its strength. In the Latin square, what I'm doing is I'm using an experimental plan to look at the order or the sequence of events. In the Solomon 4 group, what I'm doing here is I'm using random assignment to two control groups and two experimental groups. So I'm adding a little bit more here, essentially the 4 group. I'm gaining a little bit of strength, perhaps, over the pre-experimental groups by having two control groups and experimental groups. And then finally in factorial, what I'm doing is I'm using an experimental plan, but here I'm looking at the impact of several independent variables. Now, with factorial, I'm going to have a slightly weaker ability to make a causal relationship existing because I have so many independent variables acting. Okay, and so now you can see here essentially what I just discussed in a slightly different fashion here. Again, the R's in all of these cases stand for my random assignment. The X's, as you see them, stand for my treatment. The circles stand for my groups, control group or experimental group. And the deviations you see here, X, A, B, C, D, etc., that stands for treatments being repeated. And the Z1, Z2, Z1, Z2, that would stand for multiple independent variables. And so then what you see here, I think this is a pretty good comparison of the experimental designs. You would want to reference these in your research assignments as they come because you're going to want to justify why you're using a certain experimental design over another. Okay, so now we need to deal with the internal validity versus the external validity. And in the internal validity, what I'm doing here is I'm looking at the ability of the experimenter to essentially strengthen the rigor of a causal explanation. So this is important if only because what it means is that I've designed the experiment so that there's a really close relationship between my independent and dependent variable, right? Something, again, primarily comes from me very precisely defining my treatment or very precisely defining my independent variable. And in the external validity, what I'm doing is I'm making some generalizations of my finding to go beyond the study and talk about future studies that I could do. So if we look at the threats to internal validity, by far well, we're going to talk about 12 different threats here on this slide and on the next slide. By far the biggest threat to internal validity, in my opinion, is the selection bias. Is that, did you place people in groups with something other than randomness? If you did, I'm not going to trust the internal validity, straight out. Like, I'm just not, as a researcher, I would not trust it, and I think you'd be hard pressed to find a researcher who would trust your design if you do not use randomness. Okay, and then you've got history. So is it the case that something occurred during the experiment that you can't control for? Is there something that happened during the experiment, something beyond what you could control for, that could be affecting your independent variable? Well, if it is, then you've lost some of your ability to make a causal relationship. Then you've got maturation. In maturation here, you basically, the longer you take to conduct your experiment, that would be the maturation process. In the maturation process, the longer it takes, the less ability you have to say that there's a causal relationship that exists. In testing, what we're doing here is that it might be that I don't have a good way that I'm measuring through the pretest what exists. That my pretest is basically flawed. In instrumentation, what I'm saying here is that I don't have reliability of the ways in which I'm measuring things. In experimental mortality, it would essentially mean is that, are my participants, are they participating enough? Are they making it through the experiment itself? And then in statistical regression, what I'm saying here is that there's a threat that's caused by extreme values existing, right? That we see in any sort of statistical relationship that there are extremes. Well, is it the case that there are too many extremes and not enough things going on in the middle? Then, number 8, I have another threat to my internal validity. I'm not sure why my Y got cut off, probably my picture. My threat to internal validity would be my diffusion of my treatment. Here what I'm saying is that I'm looking at, I've got a problem that my treatment is spilling over to other aspects and of the person's life, and it might not be that I can make that causal relationship now between a single independent variable and not, simply because the treatment is affecting other aspects of their life. Right, so an example of that would be something like, I tell a person, I say that when people get dogs, they heal faster from some surgery or whatnot. Well, it may be the companionship that comes with the dog, but what if in the process of walking your dog, right, you're engaging in more exercise? Then it's not necessarily the dog, it's just more exercise. So now you can see that the diffusion of the treatment is essentially spilling over to other activities. In compensatory behavior, what we're seeing here is that part of the control group is modifying their behavior or making up for not getting the treatment. So that group might say, okay, I'm going to work harder to get better because I know I'm not getting the medication. I know I'm getting the placebo. Well, as they do that, that then affects their as they try harder to get better, that's going to affect my understanding of what not getting the medication. It's going to cause me to underestimate the extent to which not getting a medicine helps a person heal. In the experimenter expectancy, what I'm saying here is that the experimenter is indirectly making participants aware of the hypothesis. And so if I, as the experimenter, is telling you my expectations, then I'm going to create a problem because my participants are going to try to meet my expectations. In-demand characteristics, the 11th threat to internal validity. The problem, it's kind of related to experimenter expectancy. Now here what's happening is that my participants are picking up clues about the hypothesis. So here it's not the experimenter that's doing this, it's just that your subjects are finding out in some way what your hypothesis is, and then they're changing their behavior. And then finally, in the placebo effect, and you'd be amazed how much this one occurs. In the placebo effect, an individual did not get the treatment, but they think they did, and they act as if they did. In the manipulation check here, so now we're looking at something slightly different here, outside of the threats to internal validity. In the manipulation check, what you would do is this would be a way that I measure my independent or dependent variable, and this is the way in which I try to get some measurement validity, not internal validity, but measurement validity, or some way in which my experimental design, I can determine whether it's realistic. So manipulation check is just saying, is this real? Is this something that we would expect to occur? Now it's important because if you conduct that manipulation check, then you are increasing your internal validity. Then we've got the external validity. Within the external validity, what I'm talking about here is, are the results that I found, are they giving me results that I can generalize to the rest of the population? If I can, then I can start to design some further research projects from it. Then we've got the naturalistic generalization. With a naturalistic generalization, what I'm looking for here is the realism. I'm looking at, is this, if the design is such that it reflects the world that we think exists around us. If we don't think that this is too theoretical, then we have a way for talking about human nature. And if we look at human nature, then we start looking at broader sets of the population. Now, the other way to make a generalization would be theoretical, right? That I could say that this is one specific thing that affects some specific subpart of a theory, but it might be that for external validity, I want to make a generalization to an entire broader field of knowledge. And that's what you start to see here. In the population's generalization, I have my participants, and I believe that there's some way that I'm going to generalize to the entire population. In my naturalistic generalization, I have my controlled experiment, my findings, and again, I'm saying, is this realistic? Is this natural? Is this part of human nature? And I'm making generalizations to real life, natural or human nature situations. And then in the theoretical generalization, I've made a theory or study that applies to a very specific thing, but then I'm generalizing to a more abstract theory. Now, you do have to think about some practical considerations as well. In this class, for your projects, you won't have to think about these as much, especially the first part is that you're not going to really be engaging in planning or pilot tests, but these would be the ways that you test your experimental design before you distribute it to a larger group. You'd also want to spend a great deal of time about the instructions that you're going to give to the subject, and you're going to do that because, again, you're trying to hide your hypothesis from your subjects. And then you're going to need to think clearly about your post-experiment interview. You're going to want to think about some very specified way in which you're going to talk about the experience they've just had in the experiment without revealing too much, but just enough. Okay, so that concludes chapter 9 here, and hopefully that gives you at least a bit of an overview of how to design experimental projects.